I've been involved in the Drupal community since late 2005, 2006, and I've seen the evolution of the CMS from 4, 5, 6, 7, and now 8. And I've also been involved in different projects that are available on Drupal.org. Now, today we're going to look at how Drupal 8 works, and we're going to see how request is changed to response. Now, web applications usually do one thing, mostly, and that is the response is received from, and then the server replies with a response. Now, the application takes the request, and a lot of things go on inside that whitish square in the center, which we are going to see later. Now, with a centralized request handling mechanism, all requests pass through a single handler. And this concept is the front controller design pattern, which isn't unique to Drupal or to web applications in general. So I've got a couple of examples from the Java world. Now, that's just a definition of what a controller does. According to Martin Fowler, a controller that handles all requests for a website. But like I said, it isn't peculiar to Drupal or to web applications. That is from a J2EE application. You can see the client, the controller, the dispatcher, the view, and the helper. You can see the request coming in. The request can either be delegated or forwarded or processed. Another one from a similar application. You can see the client, main server, model, flow manager, view, assembler. This has got nothing to do with the web. It's got nothing to do with Drupal. But that is the design pattern implemented in Drupal. Now, that is the index.php file in Drupal 8. And that is our front controller. It's our front controller, right? And everything that goes on in Drupal 8 is here. You can see there are about 13 lines, I think, plus comments, but only 8 lines of code. And the first two, they're not really absolutely essentials. So we can see everything that goes on from request to response is in those 6 lines. Anyway, let's take them line by line. Now, the first 2 lines are very similar, and use Drupal core Drupal kernel. Now, a couple of years ago, I tweeted, right? What would a marriage of Drupal and Symfony look like? This is it. That was even before Drupal 8 decided to use Symfony components. This is it. You can see the symbolism in that class, Drupal kernel. Drupal kernel. We shall see what that stands for in a couple of minutes. Now, these 2 lines simply tell us where those files are, where those classes are. And it's just to give us the namespace of the Drupal kernel class and the request class there. Okay? And namespaces allow unambiguous references to objects, functions, or variables. And We could have done without the namespacing because they use just ones each. That wouldn't affect the application at all. So the main component of a Symfony is HTTP Foundation, which is just an object-oriented programming abstraction of the HTTP specification. And as we know, that's a stateless protocol. However, the Symfony request object sanitizes an incoming request, encapsulated in a single PHP object, which represents the request message. We shall see more on this later. So, the next line, line 3, we get an autoloader. What's this? Now, PHP passes your script from top to bottom, and when it comes across that line, it includes the contents of autoload.php at that particular point. It's like a virtual copy and paste operation. And OOP developers, of course, they love classes. And the more files, the better. There are thousands of files in the vendor directory, if you look under it. Some, just one line of code, and hundreds of lines of comments, tens. We love it, we love it, we love it. So you find that a single app can have hundreds or thousands of files. And then we will have to require once a number of files at different points of the code. That's going to be very, very difficult, right? You can see you get 5. Do you think that's too many? You should look into the source codes of some PHP applications. For example, WordPress. You see lots of this, lots of this. If only that could be done for us automatically. And that's why autoloading comes into place. Automatic. Someone says, we love it, we love it. And this isn't new in Drupal at all, because we've got our module load include. It's a similar concept, but doing require autoload doesn't actually do away with module load include. It's still there in Drupal 8, but under a different name, but it's still there. We've still got it. So now, like I said, the vendor directory has got all sorts of packages, different authors, different projects. If only there is a way to sort of do that. And that's why PSR4, some projects got together and then agreed on a specification for author-loading classes from 5 paths. That means if you follow a convention, of naming your classes, of organizing your files, the autoloader finds it and your code will be available. This is just an example from Drupal, of course. So if you've got your custom module, you've got the source, then you've got the folder, and then the autoloader will find your classes, will find your files, and load them. Okay, so that's what the autoloader does for us. Okay, now, however, if you look at the autoload.php, it's got that line. And then you jump again to another autoloader, okay? And that's because these packages are managed by Composer. There has to be a way to sort of do it, and then Composer has to find, has to detect where it is, so that it can actually do the loading for you. And that autoloader that we come across in the first line of our code, that's where it comes from that Composer class, and the get autoloader method there returns that. Now, the next line, we've now got our autoloader. That's line 4 now. We create a kernel instance, Drupal kernel instance. And that is the HTTP kernel with some, what I call Drupalism sugar. And that includes some concepts that are unique to Drupal, you see. Things that used to happen in the bootstrap levels. Excuse me. Massaging environment variables and all sorts of things, right? So that's what that Drupal kernel does. Let's see what does it do. And you can see Drupal kernel implements Drupal kernel interface, and then Drupal kernel interface extends HTTP kernel interface and the container aware interface, something from Drupal itself. So you can see that we haven't lost everything Drupal to Symfony. We are still there. We are just keep hanging on there. Okay? Right. And the HTTP component from Symfony provides a structured process for converting a request into a response by making use of the event dispatcher component. That's from the Symfony documentation itself, right? So now, if that's everything a website does, request in, response out, wax on, wax off, right? Request in, response out. We should expect that interface to be massive. Lots of methods, different things happening right, left, or center. However, just one method. Handle. That's everything that happens, right? The rest, the comments, of course, enough said. It's more than half the contents of that class, okay? But just one method. And that's everything that happens. You can see it says the handles a request to convert it to a response. That's something we have to stress again and again. Response in, response out, and only that method does that. We shall see how it does that further down the line. Now, next line, line 5 of our code. Remember, index.php, our front controller has 8 lines. We are now on line 5, where the request object is created. And like I said earlier on, as you saw, the request object is an OOP abstraction of PHP superglobals. So these are superglobal variables, and the request contains some of the others, and the ones that are present needs to be in a specific order, which is the request order that is set in php.ini file. So you've got things like EGPCS. So that's going to contain the env, the get, the post, the cookie, and the session in that order. Okay? However, if request order is not set, it then defaults to the variables order setting, also in php.unify, which follows the same pattern. So different environments have different variables. So that may sound confusing. Okay, so that's why the request object is very important. It abstracts everything, and then you've got a PHP object that you can work with. You don't have to worry about what's there, what's not there. Everything is handled for us. So we've got our kernel, and the next line, that's where the request is handled, right? That's where our request is handled, and that's everything that the kernel does, right? Like we've seen before. Now, the first thing that happens, it happens in the Drupal kernel, of course. There's a handle method there. And this handle method steps through this. This is something like the pseudocode for that. It boots the environment. These are things that happened in the bootstrap levels before in Drupal 7. Then initialize the settings. That's the settings.php loaded, and all the variables there is made available. Then it checks, is Drupal installed at all? No? It then prepares the response to that, which is to go to install.php and then start installation, right? Assuming Drupal is installed, it then calls the boot method. That boot method builds the service container. Right. Remember, you've got your autoloader. You've got all those classes that need to be made available. The Symfony component does that in a beautiful way by this service container, which is part of the dependency injection container. And that is to compile, to make a register of all those classes, the dependencies, what needs to be done to initialize any object at all. Everything is in that service container. It's like a big array of objects indexed by the key, right? And it's optimized. So that service container is built at that point, the boot method. Now, it now calls the handle method of the HTTP kernel itself. We shall see what happens in that in a second. And then prepares a response and returns it to the caller, in most cases, the browser. Symfony handle method. Well, there is handle method in the HTTP kernel. However, these steps here are not there. It's just to make it look nice, you know. We've got we've got Drupal handle method, Symfony handle method. It sounds better. However, inside the HTTP kernel's handle method, there is an abstraction to method in that same class, handle raw. So that's what happens in the handle raw method. Okay. A number of things also take place there. However, these are the most important things. Now, the request is pushed onto a stack so that it can be managed nicely. And then something happens. You know, I talked about the event dispatcher briefly. I mentioned that briefly. That's also from Symfony. And it's a way that allows the parts, the components of your application to talk to each other. Something similar to our hook system. Is still there? The hook system is still there. It's something like that happens. However, it's also an OOP way of handling that. And it's just like this. When an event takes place, it's dispatched, it's broadcast, it's announced. It's like saying, anyone out there? I'm finished. And then it announces that, you know. And then you've got listeners that subscribe to those events. They can ask, are we there? Oh yes, I'm here. And then it then goes ahead and then carries out the function in response to that dispatched, to that broadcast event. So after the request is pushed onto the stack, the kernel events request event is dispatched. And then lots of things take place. One of them happens in the router component of the system. And that's what looks at the request, looks at the path to the resource. Sometimes you have to build it, sometimes it's there. But it identifies the path to the request. And usually, in the root, you will see the controller, which is the method, the class and the method that handles that particular request. That's similar to what used to happen in Drupal 7's menu, something active handler, I think. I can't remember that. That method, okay? That function is similar, where the path in the hook menu is identified, and then the callback and all that kind of thing takes place, okay? So here, the controller responsible for that path, for that route, is loaded. And again, the event is dispatched. That's the kernel events controller event. And other parts of the system then respond and do their thing. Okay. And then the controller is called, the method is invoked. After that, the kernel events view event is dispatched also. So we've now got the response. Then the response is then filtered and then returned. Okay. After that, the response, that's the next line, the line 7, send a response. Now, two main things happen there. And the first one is send headers. The send headers method is called. Now, that's where the HTTP headers are now set. Now, the first one there, you discover, is the date. So it's separate because as part of the specification, the date must be set. So that first one is set, and then all the headers are now added. Okay? That's where you set the status code, the 100, 200s, and the 300s, 400s, and 500s, and cookie headers, everything set there for you in, of course, in an object-oriented way, right? Some of the subscribers to those dispatch events might have done all sorts of things. But at that point, the headers are there, and then they're then set. In that same send method, we have the send content. Excuse me. Okay. Of course, that's the body of your response, right? And it must be of a value type. You can see the MIME types, right? It could be anything. As you can see there, you can put on a string, a number, null, object that implements a toString method, and then the correct format, right? It could be HTML, JSON, XML, text. It could be a video file, an audio file, any recognized MIME type, okay, can be returned in your response, and that's your response, okay. Right. And the next one is the post-response phase. The post-response phase, that's just the last line of the index.php file, which is the terminate method of the kernel class. Now it takes in the request and the response, because it's now time to clean up after all these things that might have taken place. Things known and things unknown, of course. And you expect that method to be big, but no. It simply says, "I've finished," and that's it. Now, the kernel events terminate event is then dispatched. That's all it does. Now, let's have a look at that closely in Drupal, okay? In Drupal 7, you can see something similar happening, and that is the Drupal page footer function. You can see the comment simply says it all. That's copy and paste from a Drupal core, right? Performs end of request tasks. And if you look at the sequence, it is the same thing that happens in Drupal 8. Even the comment, you find a comment in one of the methods in Drupal 8 that says, this is just exactly what happens in Drupal page footer. Okay? Let's have a look at that. When you subscribe to an event in your get subscribed events method, you specify the callable. In most instances, that's a string that represents the method in that same class you want to call, and then a priority. The priority is the order in which you want those methods to be executed, and is the reverse of Drupal wait, because -10 happens before +10, right? But for events, the bigger, the better. Okay? So the first one, that's the one, the priority 300, and that's when the current user's last access time is stored in the database, because there are many requests coming and going, done more frequently than once in 180 seconds. That is the default, but you can change it. If you like, up it, drop it. It's all in your settings.php file. Okay. And the next one in the priority, the 200, and then the system paths are all cached. System paths cached. And then the next one is in the automated cron class. Automated cron is run if enabled at all. And then the caches are written, and that, yes, and that's where the comment that I mentioned earlier, that everything that happens in Drupal page footer happens here, you see? And finally, the kernel destruction subscriber, which is -100. That means that's really, really the last thing you want to do in your terminate method. And that's what destroys the initialized services, the service container, the compiled list of all those classes, and the paths to the files. That's where that is cleaned up for you. We'll soon finish. So, we've come back to where we started from. The request comes in. You've got your Symfony and the Drupal interacting, dispatching events, and handling those events. And then you have your response at the end. That's it. There's something else. Yes, I wanted to add something, and that's the fact that this request object, there's a PSR7 movement that actually broken that down. There's a specification that says you've got your message, you've got your response. However, there are some other interfaces that can be written and implemented to allow for interoperation between projects. So PSR7 is an extension of this talk. That's something that you can actually look at afterwards to see how that single object, that single class, has been broken down into like 5 or more interfaces by the PSR7. That's it. Thank you. You can see my details there. My GitHub repository is there. And the last link there, that's the join.in. And you can give feedback to the talk /6E65C. Thank you. Any questions? Okay, that's it then. Our time is up. Thanks very much.